After devastating floods, flash floods in Nepal, there are a lot of satellite images that are coming up, uh, uh, showing the extent of destruction that has happened, and also suggesting what could have been the trigger. So, to talk on this, we have a geo-intelligence expert, Professor Y Nithiyanandam, who is also the head of geospatial research, Takshashila. So the first question is, what triggered this flash flood, this devastating flash flood in Nepal?
So, thank you for having me, ma'am. First thing, when it was projected that a flash flood has happened, and by looking at it, immediately it resembles like, due to a glacier outbreak, right? Then what we have found out is, at least in our quick analysis, we could able to see there is an earthquake, uh, which was put out by United States Geological Survey, right on the, just probably on the straight line above the hill, and which could have probably triggered. That is an initial inference. That, to be very precise, it was like, 30 kilometers above the place where the impact I've studied. And this is the epicenter was right above 30 kilometer from that point. But this was a scenario till that time. But then later, in the evening yesterday, the USGS also, reworked on their inference, and then they said the earthquake was not 4.4. It was revised as 5.2, and more than that, they also said the earlier we felt the earthquake is something which has triggered this landslide, but later on they clarified the landslide is something which has triggered the earthquake. So it is that big that from there on people are looking at it from various angles, and in fact we are also studying it from various angles and what could be the possible causative factor for this bigger landslide.
So when we talk of magnitude 5.2 landslide, this means a landslide which caused a 5.2 magnitude earthquake. Is it so, sir?
Earthquake, yeah. Yeah, the 5.2 and 4.4, what I have said was the Richter scale, the magnitude of earthquake, which was triggered due to this landslide.
Okay.
That's basically the glacier which has slipped away. And because of that, it is so massive. Because of that, the earthquake has triggered.
So you must have got the satellite imagery with you. What is the extent of damage that has occurred?
The detailed satellite imageries are coming up slowly because we should remember that there are two possible ways in satellite imageries can help us to understand the impact. One is from the optical data set, the other one is from the synthetic aperture radar data sets. The optical ones are very easy, and that you are seeing which are floating around in internet, but it was quite cloudy, and we have limited understanding of what has actually happened in different parts of the river stream. But what we are when we are looking at the place where it is marked as a glacier has slipped down and so on, the extent of the glacier is quite visible. It is very big, and it is in fact it is not towards the Nepal side. The initial slip has actually happened. When we look at the satellite images, it shows the initial slip has happened towards the Tibet side, and the glacier is within Nepal, but the way it has slipped, it has moved towards the side of Tibet, and that's a natural course of the river. And thereafter, it came back into the Nepal. So it's basically the slip which went on its natural way, and it has crossed the boundary and come back into the Nepal. In this case, what would have likely happened is, the snow cover has been reduced over a period of time in this area. But this is something what we are largely understanding on this region, especially in the border regions, where the snow cover has been reduced, and then you get increased rainfall. When the snow cover is reduced, snow or it's very high albedo, it's very bright light, and it melts also faster. Now when the snow cover is gone, the surface is exposed glaciers. The glaciers are not something like one can go and easily break. Those are very thick sheet of ices. You can say, in fact, those are like kilometers of height as well. In this case, it is moving around in internet that it is of 1 kilometer plus of thickness also. So
Mm,
this thick glacier slips down. It's more like taking a big piece of ice, keeping on a flat slope of surfaces, and it slides down, right? So
mm,
it happens in the same fashion. And again, the glacier is not bright. You can see the albedo, the brightness of the surface of the snow is bright, whereas this glacier is not bright. Since it is not bright, it traps more heat from the sun. So
mm.
basically, it tried to slip faster, it tried to melt faster, and that is the reason we are seeing even the temperature on those surfaces, near surfaces of this glacier were higher in recent times. So because of cumulative factors of all this, the glaciers have melted down faster, and in this case, it has slipped. A big sheet of ice has slipped down. But is it a condition only with this particular glacier? The answer is no. Most of
Mm,
these glacier lakes in this region are fragile,
mm.
and it has been continuously monitored.
This year
Yeah,
only in the parliament, uh, it was told that there are around over 50 glacial lakes, which are
yeah,
at a very high risk of
yes,
growth.
yeah.
So, are you
There,
monitoring? Are you monitoring
no, we are.
those high risk lakes, sir?
What we are looking at whenever this kind of cases happens and it critical infrastructures, we are looking at the possibility of impacts of these glaciers.
Mm.
When this particular fragile glacier is impacted, what could be the potential impact on the downstream? That is something we are looking at certain areas of our interest. But certain things we can monitor, even the thickness we can monitor to an extent from space. But it requires the people on ground, people on space to, I mean, the remote sensing technology and people on ground to work together. And of course, the ground monitoring is very essential on this thing.
How can geo-intelligence help in that?
I could say we should not use the technology to see the postmortem of the incidents. We should
Mm,
use the technology to predict the things before it comes. And
mm.
geointelligence is something you sense, understanding the severity of these glaciers or any kind of disaster, and feel there is a possible impact on a particular downstream, and modeling it and looking at who is living, what kind of developments are happening around. If and when any of this kind of incident happen, what could be the potential impact? That is where geointelligence comes in. It could be a civilian settlement below that area, or it could be a military establishment below that area. But it is essential to understand the potential impact, model it, predict it, and prevent it is something where geointelligence comes in rather than doing the post event analysis.
What are the specific geographical characteristics of the area that caused, that magnified the damage?
These are
Mm,
high altitude areas, and I told the causative factors are the change in climatic conditions in these areas. So in this case, I would say it's a mix of multiple things which have triggered. But this is something where a wake up call. What we need to do, or any downstream country should do, is better cooperation with an upstream country, especially in terms of getting meteorological data sets, in terms of understanding early warnings from them, in terms of understanding the possible trigger factors, as you rightly asked. All
mm.
those things need to be studied in depth, and more importantly, joint scientific studies should also be needed.
So, Professor Nityanandam, the internet was flooded with speculations that because of some kind of construction, the Chinese Xiaokang villages that are being built, and to build that village in that particular area, the course of river was changed. That is the reason why this flood uh, came. So
So,
it was speculation, but is there any kind
no,
of
I think I
uh,
still consider it as a speculation, but then, there are two ways it was told. The first one was people were saying that it is triggered because of Jiokong village construction. So
mm,
now I will completely rule out this from the initial analysis. And of
mm,
course, it is just based on initial inference what we have studied. Because to trigger a glacier at this scale, any construction, let's say construction of a small village or even a city, it's not going to impact in this way. However, the course of the river point, I'm not sure, but then it looks like a natural course where the slip has happened and it just fall into the river stream. And the river stream, of course, it does not know the boundaries between countries. Has been in that area, but then the structure you are seeing, like, very famous structure we have seen, the entry point between two countries, the China and Nepal, where it has
Mm,
completely taken off and the muds were flowing at a pretty high altitude. I think that was the construction in the middle of a river. But
mm,
other than that, I don't know about the Zyokong village over there. But I don't expect much of correlation between construction of a Zyokong village can leads to a
yeah.
glacier slip and so on at this scale.
Yeah. And now we are also hearing about Chinese dams being built on the, as we were speaking
Medong.
earlier,
Yeah,
yeah, Midok County, and it is on Yalung River, which becomes
right, right.
Brahmaputra in India. So, do you think these dams on Chinese sides, it is not only a single dam, they have multiple dams
Yeah.
on Brahmaputra only. So, do you think this is a threat also?
See, this is a wake up call, and this is definitely a threat if the bigger dam is built over there.
Mm,
Wake up call in a sense that again emphasize the need for cooperation, data sharing, and need for joint scientific explorations and experiments and so on. On the other side, when it comes to threat, what you have here in this particular place, you have a similar challenges on that place as well.
mm,
We have glaciers right up there, and it is again placed on the dam is likely to come on a place which is of what do you call um, more landslide susceptibility exists in that place. And
mm,
then again, it is in a seismic zone where it is highly sensitive, and
right.
hundreds of earthquakes happened in the past.
Mm,
And more than that, it is also you also pointed out that they have constructed multiple dams in the upstream.
mm,
The cascading of dams are built. So now, what could trigger whether we will get a similar quantum of water. It depends on what size of the reservoir it's going to be. Since it is a run of a river, the reservoir would be of a relatively smaller size.
mm,
But if that anything happened to any of the glaciers which are there, right,
mm.
then the impact would be different. I think that is something where we haven't put out much of thought on what could happen to the glacier melt. And it was expected to be a pretty soft action of melting over the years, but then if it creates something like this, then it is a challenge. But definitely the impact would be on the downstream
You are
as well.
suggesting that even if they don't release water and some glacial lake, it breaks down and then it affects all the dams that have
So
been
there's
built on the way,
so at
as it
that
affected in
particular
Nepal.
region.
Yeah.
Yeah, in that particular region, you don't because the Yarlung Sangpo in other areas, typical glaciers in that exist in the very upstream. It is not in the midstreams, so it is safe to have all those things. But in the fag end, you have few pockets where you have the glacier lake. Now, in that fag end, you have pretty heavy rain also. Now, the
Mm,
rain increases and the snow decreases and the glaciers are exposed. That is
mm,
only in the fag end. But then the Yarlung Sangpo, the glacier melt happens in the pretty, in the early stage of the river. The midstream is
right.
largely shallow and you don't have much of, sources from glacier melt.
Mm.
But I'm worried about the last leg closer to Arunachal. If, you know, if there is because that is an area where you have, uh, what do you call, the deepest canyon in the world, which has an elevation difference of 2000 meters drop.
This
So
is
the
near
impact would be
the
much higher and
Great
serious.
Bend. This is near the Great Bend.
Right. This is after the Great Bend, the elevation dips down. But it is anything that you do is very speculative. We need to be proactively, once there is the construction happens, then we should be prepared. We should think of rather preventing these kind of scenarios. And the simulation should be carried out to understand the impact on downstream, and also whatever likely impact it can create, and close coordination with the developments happening in upstream would be the solution, rather just getting scared and thinking of similar or expecting a similar event in near future is something we should avoid, and we should be prepared for that possible things. In fact, looking for actions on downstream, whether we should construct more and more dams, or should we look for more observations, and should we go for innovative technology to understand the possible developments happening on those surfaces, river runoffs, and various other contributing factors, is an important thing to focus on.
Thank you. Thank you, Dr.
Yeah.
Nithiyanandam. Thank you.
Yes, you're welcome.
Thank you.